Hello students, we discuss question number 5 of paper 2. Consider two isosceles prism 1 and 2 with prism angles A1 and A2 with respective indices N1 and N2 respectively as shown in figure. The faces A1, B1 and A2, B2 are parallel to each other and perpendicular to the mirror M. If a ray of light is incident on the face A1, C1 and emerges from the face A2, C2, then the correct statements are. First we draw the diagram. This angle is theta, it is I1, it is E1 and it is I2 like this, it is A2, it is A1. Suppose it is R1 and it is R2. Now it is a mirror, just see here. If this angle is I2, it is 90 minus I2. If it is I1, it is horizontal line, it is 90 minus I1 parallel to mirror. That means these two angles are equal, therefore E1 is equal to I2 for all cases. In the first option, is given that if both prisms are in minimum deviation condition. In case of minimum deviation, this angle is A1 by 2. So N1 sine A1 by 2 is equal to sine E1. For second prism, N2 sine A2 by 2 is equal to sine I2. And E1 is equal to I2. So we write N2 sine A2 by 2 is equal to N1 sine A1 by 2. And in the first option, we find N2 by N1 is equal to sine A1 by 2 divided by sine A by 2. So it is correct. It is A option. In the B option, when prism 2 is at minimum deviation condition, only prism 2 is on minimum deviation condition, that means 1 into sine I2 is equal to N2 into sine A2 by 2. And I2 is always E1. So 1 into sine E1 is equal to N2 sine A2 by 2. And E1 not equal to I1 because it is not condition of minimum deviation. So sine I1 does not equal to N2 sine A2. So B is incorrect. In the C option, when angles are small, then delta M1 is equal to N1 minus 1 A1, delta M2 is equal to N2 minus 1 A2. In this case, delta M1 upon 2 N1 minus 1 plus delta M2 upon 2 N2 minus 1 is equal to, from this equation, A1 by 2 plus A2 by 2. Now, see here. In this case, this angle, in this diagram, suppose this angle is theta 1, this angle is theta 2. So, this angle is equal to this angle and this angle is equal to this. So, it is A1 by 2, it is A2 by 2. Sum of these two angles means sum of these two angles. That means A1 by 2 plus A2 by 2 is equal to theta. It is equal to theta. So answer C is correct. In the D case, in the D part, sine I2. In the D option, prism 1 is minimum deviation. So in this case, if we write n1 into sine a1 by 2 for first prism is equal to 1 into sine e2 and sine e1, and sine e1 is sine I2. So it is correct. So D option is correct. So answer is A, C, D.
Hello. So here we are going to do question number 6, second paper advance. So what we have given here we have given charge 1 microcoulomb, and if we will change in the SI unit, so it will be 10 to the power minus 6 coulomb, and this charge is entering first in the electric field, and then after some time, after 0.2 second, the magnetic field will switch on and the electric field gets switched off after 0.2 second. So what we have to find here, let's say, so, and the mass of the particle is given 1 milligram. If I will change into the SI unit, so it will be 10 to the power minus 6 kg. Okay. So what we have given here, the particle is here, and let's say this is x-axis, this is y-axis, and this is z-axis, and the particle is entering perpendicular to the xy plane, xz plane. So here's the xz plane. So particle is entering here, and what is the initial speed of the particle? So velocity of the particle is I cap plus 2j cap. It is given in the question. Meter per second. So here I cap and 2j cap here. So let's say the particle is entering here with the initial speed u. Now what is going on here? Initially only electric field is acting here and the gravitational field is acting for the complete motion. So for 0 to 0.2 second, if I will analyze here, so what is the electric field is given? E equal to 1 I cap volt per meter, and gravitational field here we can take minus 10 j cap. So electric field is in the plus direction plus j, and gravitational field is acting downward minus 10 j cap. And first we will analyze from t equal to 0 to t equal to 0.2 second. So what is the force acting on the particle? Electric force acting equal to q times E vector. So now what is the charge of the particle? Charge of the particle is 10 to the power minus 6 coulomb. And what is the electric field here? Electric field is 1 I cap volt per meter. So if I will solve this one, I'll get 10 to the power minus 6 Newton force. That is the electric force acting on the particle. So what is the acceleration because of the electric field? So acceleration because of the electric field equal to mass times acceleration. And if I will write the mass of the particle is 10 to the power minus 6 kg. So what will be our acceleration here? So acceleration of the particle becomes, what is the direction of the force? Force direction is, electric force direction is plus j cap. So I can say acceleration becomes 1 meter per second square along, sorry, it is along the I cap. So electric field is acting here, electric field is acting along the x direction, gravitational field is acting along the negative y direction. So I can say the net acceleration on the particle because of the electric field and because of the gravitational field. So because of the electric field, what is the direction? Along the I cap. So 1 I cap means I cap. And what is the acceleration because of the gravitational? Minus 10 g cap. So here's the net acceleration acting on the particle for the time interval t equal to 0 to t equal to 0.2 second. So what we can find here, after 0.2 second, what will be the condition here? So let's say the final velocity after 0.2 second is v vector u plus a vector t. First equation. So now we will analyze for the x direction and y direction and z direction. So for the x direction, what is the vx here? Vx equal to, I can write ux plus ax t. Now what is the initial speed along the x direction? So initial speed is 1 meter per second. So 1. What is the acceleration along the x direction? So 1 into t. What is the time after 0.2 second we have to find? So it will be 1.2, and this is along the x direction, so vx. Now what about the vy? The speed in the vy direction after 0.2 seconds, so we can write uy plus a by t here. So what is the initial speed along the y direction? Initial speed along the y direction is 2. Now what is the acceleration along the y direction? Minus 10. So minus 10, and the time is after 0.2 second. We have to analyze this motion. So how much is this? It will be 2 minus, from here also again we will get a 2. So this is 0 meter per second. It means after 0.2 second we have the complete velocity along the x direction. It means the particle is moving something like this, and after 0.2 second the particle becomes exactly along the x direction. This is your v vector. So this is at t equal to 0.2 second. Okay, so now the particle has the velocity only along the x direction. Now we will analyze the particle after t equal to 0.2 to, I can say, whatever time is given. Let's say after 0.2 second. Here. Okay. Now magnetic field will turn on after 0.2 second. So electric field is off. So magnetic field on and electric field off. So now because the magnetic field is on and we have the velocity of the particle here, so we can say that here force will act F vector equal to Q V cross V. This is the magnetic force. So here we can write what is the charge here, 10 to the power minus 6 coulomb. What is the velocity of the particle? 1.2 only along the x direction, so I can say 1.2 times I cap cross. What is the direction of the, what is the magnitude of the B? Magnetic field is given here 6 along the j cap. So from here we can get the force equal to, because of the magnetic field, 1.2 into 6, this is 7.2 into 10 to the power minus 6, so this is 7.2 into 10 to the power minus 6 Newton. Now from here you can say I cap cross j cap equal to k cap. So now the magnetic force is acting along the k cap. What is mean by this one? Now the magnetic force is acting here, gravitational force is acting downward. So I can say from the F equal to Q V cross V, what is the direction of the force? Along the k cap, and gravitational force is acting downward. So I can say here
Yes.
it means only gravity will act along by direction, because what is the direction of the magnetic force? It is along the k cap, and we are analyzing along the y direction, so only gravity is acting here. And what is the magnitude of the gravitational force? You already know, it is 10 meter per second square downward. Now so from here we know that the Vy equal to 0, so I can say the velocity along the y direction was 0. And we can find what is the position after 0.2 second of particle at 0.2 second. So along the y direction, what is the position of the particle? So I can use y equal to u by t plus half a by t square. So from here we can say, so what is the velocity? 0 minus half, what is the value of the gravitational acceleration? 10 t square. So if I will take here the velocity by equal to here, actually initial velocity was along the y direction 0.2. Initial velocity was 2 j cap, so 2 into 0.2 minus 10 gravitational acceleration into 0.2 chi square time chi square. So from here we'll get 0.2 meter, and that is equal to 20 meter. So the particle reach here along the y direction 20 centimeter. This is in centimeter. Okay, now magnetic force is acting along the k cap, gravitational field is acting downward. So we can say in the options what we have to find here, we have to find where is the particle at 0.3 second. It means from 0.2 to 0.3, what is the displacement of the particle along the y direction, or what is the displacement of the particle from the xz plane. So I can write here, so along the y direction what is the displacement, by equal to u by, what is the u by finally at the 0.2 second, we know that it is 0. So there is no velocity, you can say the complete velocity along the x direction. So there is no velocity along the y direction, so I can say at 0.2 second the velocity is 0, initial velocity 0, minus only gravitational force is acting downward because the magnetic force is acting perpendicular to the y direction. So only gravitational force is acting, so half into what is the acceleration because of the gravity, minus 10 into t, 0.2 0.3 for this time interval, the time is 0.1 square. So now what is the displacement of the particle in this 0.1 second? So from here you can see 0.01 into 10, so 0.1 upon 2, so I will get here in this second it will be 0.05 meter. It means this is 5 centimeter displacement will be there. So if I will count, this will become 5 centimeter, because the minus sign is here, means the displacement is negative. So from the ground, from the xz plane, what is the displacement if the particle is coming here 5 centimeter down? So I can say from here the height of the particle is 15 centimeter. So if you will see the option A, the vertical distance of the particle from the xz plane at t equal to 0.3 second is 15 centimeter. So here we can clearly see from the xz plane the particle displacement is 15 centimeter after 0.3 second from t equal to 0 second. Now next option is the vertical distance of the particle from the xz plane at 0.4 second. So now after 0.4 second, where is the particle? So after 0.2 second the particle is here at 20 centimeter height. So we have to find 0.2 to 0.4. So what is the time from here to here? 0.2 second to 0.4 second means in 2 seconds what is the displacement of the particle from here, because now the particle is here at 0.2 second. So we can say y equal to again u by t plus half a by t square. So what is the u by? Initially the particle speed is 0 at 0.2 second. You can see here it is along the x direction. So minus half gravitational acceleration is minus 10 into t. So from 0.2 second to 0.4 second means 0.2 second square. So in this 0.2 second, after this movement, what is the displacement of the particle? So minus 2 5s are here, 0.04 into 5. So here we will get directly 0.02 meter. It means 20 centimeter. It means now the particle is here. If the displacement is negative 20 centimeter, means the particle comes to the xz plane. So what is in the option? In the option we have given the vertical distance of the particle from the xz plane at t equal to 0.4 is 10 centimeter. So we can see clearly the particle displacement becomes 0. Okay, so option B is incorrect. Now come to the option C. In the option C, what we have to find? The radius of the trajectory of the particle for t greater than 0.2 second is 20 centimeter. So now, what is going on here? Look at here. The magnetic force is here, the gravity is acting downward. So because of that, the particle is experiencing the force this side, and because of the gravity, it is moving downward. So because of the magnetic field, the particle will move in a circular path, and because of the gravity, the particle is moving downward. So what is going on here? The particle is moving in the circle also, and it is moving the downward. So it will make the helical path. So now, and we know that radius of curvature for the circle, it is equal to r equal to m v by q b. What is the mass of the particle? The mass of the particle is 10 to the power minus 6 kg. What is the velocity of the particle? It is 1.2 meter per second. You can see the velocity is here, 1.2 meter per second. This is kg here upon. What is the charge on the particle? 10 to the power minus 6 coulomb into what is the magnetic field here? It is given here 6 Tesla. So from here we'll get, this will get cancelled. So this is here 0.2 meter. It means 20 centimeter. So in the option, the radius of trajectory of the particle for t greater than 0.2 is 20 centimeter. So option C is also correct. Now come to the option D. So in the option D, the particle will be at in the xz plane at t equal to 0.35 second. So from the this calculation we already got, after 0.4 second the particle comes to the xz plane. Okay, in the 0.4 second complete time, 0.4 second it comes to the ground. In this option we have given the particle will be in the xz plane at t equal to 0.35 second, but the particle is coming to the xz plane after 0.4 second. So particle will not be at the ground, it will be somewhere here, not on the ground, because after 0.4 second it is coming here, means in the 0.35 second the particle will be somewhere here. So that's why the option D is also incorrect. So what is the correct option? The correct option is A and C. These two are the correct answers. Thank you.
Yes, sir. Right. Yes. Hello, dear students. JEE 2026 Advanced Paper 2 Physics Advanced Paper 2 Question number 7 solution. So this is the diagram. Let us draw the diagram first, then you will understand better way. Right, coordinate system. Suppose here is point A, somewhere here is point P, this is some other point given, coordinates x comma y. Here you have charge q1, coordinates are a comma b. Here the charge q2 you have. Here you have charge q2, coordinates are ma and mb. That's what they have said. Okay. So what is the data given for us? Potentials are equal, right? Potential at point P due to q1 and due to q2 are equal. So v1 is equal to v2. v1 is equal to v2. v1 point charge, right? kq by r. R means distance between them. I think you know the coordinate geometry. Distance between 2 points. Under root of x2 minus x1 whole square, x minus a whole square plus y minus b whole square. So v1 kq1 by distance under root of x minus a whole square plus y minus b whole square. Potential at P due to q2. This is k into q2 by under root of ma minus x whole square plus mb minus y whole square, the distance. Okay, so under root of ma minus x whole square plus mb minus y whole square, but q2 is equal to m into q1. So q1 gets cancelled, k and k gets cancelled. I think we can square on both sides. M square will come. You can multiply this, cross multiplication. So the equation that you are left with is, this is the equation. So yeah, here itself. M square a square plus x square minus 2 m ax plus m square b square plus y square minus 2 mby is equal to, yes, this one. Whole m square you have to multiply. So this will become m square x square plus m square a square minus 2 m square ax. Similarly, m square y square plus m square b square minus 2 m square by. Okay, so keep this equation like this. So options are given for us: option A, option B, option C. See for values of m. Okay, so if you substitute option A, m is equal to, yes, what is the equation? Yeah, 1 second, let me see the options. For option A, m is equal to minus 1, there. If you substitute m is equal to minus 1 here, no? Yes, what you get is, yeah, equation is 2ax plus 2by is equal to 0, implies ax plus by equal to 0. So option A is correct. Option A is correct. Okay, that is for, yeah, option A. You have to check m is equal to minus 1 in this equation, right? Yeah, there you can check option A, right? So check option B also. Shall we check option B? Yes, now itself we can do that. So in option B, what they say, m is equal to 2. Yes. Option B, let us check it. M is equal to 2. So they are asking locus, okay, circle. And for that equation, what you get is, yeah, I think, yeah, I have to rub off this. Option B, that is for m is equal to 2. This is the equation you will get: x square plus y square minus 4a by 3x. Okay, next minus 4by by 3 equal to 0. So you have to compare this with the standard circle equation, right? So x square minus 2hx plus y square minus 2ky is equal to r square minus h square minus k square, where the center of the circle is nothing but h comma k. This is the equation. So compare this with this equation. Right hand side 0, so this term is 0. So what does it mean? R is equal to under root of h square plus k square, that is the radius. Compare this with this equation: 4ax by 3. So 4a by 3. Observe this one. 2h is equal to 4a by 3 implies h is equal to 2a by 3. Similarly, compare coefficient of y also. K you will get 2b by 3. So the locus is, okay, circle with the center, yes, h comma k, 2a by 3, 2b by 3. Yes, option B is correct. Okay, option B is correct. And option C, check option C also. What did they say? M is equal to minus 2, right? Yes, that also you can check. If you, option C is also correct. Please put m is equal to minus 2. So if you do that, yeah, let us write this here. Yes, I think we can rub it off. Put m is equal to minus 2. Then what happens? So yeah, same procedure you have to follow. Then what happens is, h will be equal to 2a, k will be equal to 2b. Okay, so the circle of radius right, r is equal to under root of h square plus a square, that will be 2 under root of a square plus b square. Option D is obviously wrong. Check m is equal to minus 3, last option, that's not correct. So for this one, A, B, C are correct.
Okay. Let's have a look at question 8 from paper 2. One of the more straightforward questions in this paper. This is about a dipole placed in a uniform electric field. The dipole is initially oriented along plus I. The charges are given minus q plus q, and the mass of each of them is m. At t equal to 0, a field is turned on along the plus j direction. X, Y. So the dipole will rotate about its center of mass and its equal masses through the center to align along the field. So let's look at the different options. So we'll just write down the angle in this is measured with respect to the x-axis. Theta final is measured with respect to x-axis, and the field is along the y-axis. So this is theta f. Then the angle with the field is pi by 2 minus theta f. Option A says the center of mass of the dipole is deflected towards j in the presence of the field. It's a uniform field, the net force will be 0, so the center of mass will not move. Then we can say the change in kinetic energy is equal to half I omega square. So will be equal to minus of delta, you decrease in potential energy. There will be minus of, initially the angle between the field and the dipole is 90 degrees. So the potential energy will be 0. Final will be minus P, which is Q, D, E, and cos of pi by 2 minus theta f. So this will just be Q, E, D, sine theta f is half, is delta k, which is equal to half. Moment of inertia 2 times m. The separation between them is d by 2. So from the center of mass it will be d. From the center of mass it will be d by 2 each. So d square by 4 and omega square. One of these d's cancels. You get omega square is 4 times QE by MD sine theta f. So in option B, it says theta f is pi by 6 sine 30. Sine 30 is half. So theta f is pi by 6. You get omega square is 2 QE by MD, or omega is under root 2 QE by MD. And then option C says theta f is pi by 3. In that case, the change in kinetic energy will be QED sine pi by 3, which is root 3 by 2. But in the options it says 2 root 3. So that option is also not correct. So far, A wrong, B correct, C is also wrong. And in option D, it says when theta f is pi by 4, so when it's at an angle of pi by 4, the field is turned off. Right? If the field is turned off, the torque becomes 0, and the dipole will continue to rotate with a constant angular velocity. So option D is correct. So it's just B and D.